Okay, this video is about the distributive property, also called distribution. I want to start with a word problem so you can understand why we do the distributive property. So in this example, you're having a gathering. You want to plan 2 drinks per person. You know that 10 people have already RSVP'd, but that other guests will just show up without notice. So this makes sense to us in real life. We understand that 2 drinks per person means 2 times however many people there are. And right now we don't know how many people there are, but we can still say 2 times however many people there are. We do, however, know that there will be 10 people there because they've already RSVP'd. But we know that there's going to be some additional guests. How many? We don't know. And that's why in this case we would call something X, because it's an unknown number. So this setup makes sense to us in the sense that 2 drinks per person times however many people we have, and we know 10 people plus some unknown number. The distributive property, or distribution, says that even though we don't know what 10 plus x, that total number of people, will be, we can still distribute or pass out that multiplication. And what I mean is, let me clean up a little. We can still say, well, we'll need 2 drinks for each of those 10 people. We'll need 2 times 10, 20 drinks. And we'll need 2 drinks for each of those other people. So we're going to need an additional 2 drinks times however many people that is. I don't know still, but I can say 2 drinks each. Now this may not look simpler, but what we've done is we've simplified this. We need 20 drinks plus 2 drinks per person. When we talk about distribution, what we're talking about is the passing out of this multiplication across other terms. So let's go to a real example now. You may be given something like this. My order of operations says I'm supposed to look in those parentheses first, but when I look inside the parentheses, I have an x term and a number term which I cannot add together. When I can't add those things together, because one is an x and one is a number, that's when I'm going to turn to distribution, and I'm going to say, hey, this 4 wants to multiply. I know because it's touching those parentheses. So what I'm going to do is I'm going to pass that multiplication out to every term that's inside those parentheses. So the 4 is going to multiply times the 2x first. And then the 4 is going to multiply times the 7. Notice there's a plus in between, so that plus can easily come down. Now, I don't typically write it out this way. I just wanted you to see what I was doing here. The way we typically write it is bringing down our equals. 4 times 2 is 8 with that x on it. That's the 4 multiplying times the 2x. Then the 4 multiplies times the 7, and we get a positive 28. Notice inside those parentheses we had an x and a number that couldn't add. In our final simplification, we still have an x and a number that can't add. That's okay, but we have done that distribution of the 4. Again, this may not look like a nice answer, and in fact, it's not an answer. It's just rewriting the first term in a different way. Let's look at another example. Here I notice in my parentheses I have three terms, a y, an x, and a constant that can't be added together. This -5 is touching the parentheses, so it's the -5 that's going to get distributed. The -5 is going to go first onto the 6y. A negative times a positive gives us a negative answer. A 5 times a 6 gives us a 30, and there is just one letter involved. So notice how I did the signs first, then the numbers, then the letter part. If it's easier for you at this point to think, okay, I've done that 6y, let's cross it off, let's be done with it, and let's look at the next thing I'm dealing with. The -5 now gets passed out to the -2x. Negative times negative, here we get a positive answer. The 5 times the 2, and then our letters. Again, if you'd like to cross off that -2x, we're done with that, and now our -5 is going to distribute on the 4. Negative times positive, and 5 times 4. If we go back to our original problem and notice we had a y term, an x term, and a constant term which could not be added together in our parentheses, we still end up with a y term, an x term, and a constant term that cannot be added together. This, as bad as it looks, is our answer. Okay, so then they're going to get tricky. Take a look at this one for a minute and see if you can tell what's different about it. So what I see here, my inclination, because of order of operations, says to go inside the parentheses and see what I can do inside there. When I go inside those parentheses, I have an x term, a number term. I can't add that crap together. When I look for possible distribution, I see that it's this -2 that's touching my parentheses. In fact, what that means is that it's the -2 that's going to get distributed inside the parentheses. This 6x is just kind of hanging out, waiting to see what happens with that -2 and the parentheses. So I'm going to bring my 6x straight down, and then I'm going to start my distribution with this -2. The -2 is going to multiply on the 3x. It gives me a negative. 2 times 3 gives me a 6, and an x with it. I'm done with the 3x. I'm going to let the -2 distribute to the -5. Negative times negative, and 2 times 5. What I have now is 3 terms waiting on this line to be added and subtracted, and I'm going to see if any of them match. I have x's and I have x's. I can definitely mush those together. 6x minus 6x. I happen to have one of these cases where my x's are gone. I had 6x, they subtracted 6x. That gives me no x's. Now I could write 0x, but in algebra we think that's kind of silly, and we just say, hey, what I have is nothing. I do, however, have this number term, so my final answer is just 10. My x's canceled out. I just had those numbers. That number is my final simplified solution. One more. What you notice I've done here is given you two sets of parentheses. Looking inside the first set, x constant can't be added. Looking inside the second set, constant x again cannot be added. So now we're going to look for a number that's touching those parentheses that we can possibly distribute. Here I see that 3 is right up against those parentheses, which means that 3 wants to distribute inside those parentheses. The 3 gets on the 2x, and the 3 distributes to the -4. This second set of parentheses is tricky though, and the reason it's tricky is because what's touching it is a minus. That minus also wants to be distributed. So the minus is going to jump on the 7, making it a -7. And the minus is going to jump on the -2x, making it a +2x. If you feel like that's unclear, please back the video up again and watch it distribute through. The negative jumps on the 7, the negative jumps on the -2x, and changes the sign of everything there. Now I have this line of x's and numbers which I can simplify or clean up. 6x, +2x. I'm going to combine those like terms. -12 and -7. This is our final simplification. We have x terms, we have constant terms. They can't be added together. We've cleaned everything up as much as we can. I hope this helps. Thanks for watching.